Thank you.
Thank you. Yeah. All right. So again, just for the record, literally for the record, the record, this is problem number 6 in section 6.2. I'm going to show this again so that it will show up on the recording. All right. So what we did here to recap is we multiplied both sides of this equation by the cosine of x, got it down to this, solved for cosine squared x, took the square root of both sides of our equation. Don't forget the plus or minus square root of the right side. And then we discovered there's 4 solutions to this equation here, one for each of the 4 quadrants. Pi 6, 5 pi 6, 7 pi 6, 11 pi 6. The cosine of which any of one of these angles would be either a positive or a negative square root of 3 over 2. Okay, now we can move on. All right, that was one like number 6. All right, notice problem number 8 would be done in a similar fashion here because cosecant can be replaced with 1 over sine theta. Cotangent theta is cosine theta over sine theta, so you would multiply both sides of this equation by the sine of theta. The same trick we used in number 6 would be employed in number 8. Same song and dance there. So I'm going to move down to one like number 10 now. Hold on a second. Let me see the instructions here. Oh, notice the instructions. It says, if the argument of any of these trig functions is theta in any of these equations, then your answers are to be degrees from 0 to 360. If your argument of their trig function is x, your answers will always be in radians from 0 to 2 pi. So problem number 10, our answers are going to be in what? They're going to be not radians, but in degrees, because theta is the argument. Okay, I'm open to suggestions as to how we're going to attack number 10. Now, what makes this difficult initially is the fact that the arguments of these sine functions are not the same. Here, the argument is just theta, but here, ladies and gentlemen, it's 2 theta. These arguments are different. So we do have a big problem here. All right. Does anybody remember, or can anybody help us by using, here's a key, a hint, using an identity to diffuse this argument from being 2 theta to just down to being theta? Anybody know what identity we would use? Give you a hint. Sine of 2 theta. What identity enables me to rewrite the sine of 2 theta?
The double angle identity?
A double angle identity for sine. And do you remember what that says? What sine of 2 theta is equal to? Recall, one of our millions of identities, ladies and gentlemen, is the fact that the sine of 2 theta is equal to what? 2 times the sine of theta times the cosine of theta. Double angle identity for sine. So that's what we're going to replace this with. 2 sine theta, cosine theta. Good. Now we got our equation down to this. What's a little disconcerting, though, is we have 2 different trig functions tied up in 2 different terms here. We have a sine and cosine. That's not good. What probably would we want to do next here? Anybody?
Factor.
All right, what can I factor out of both these terms here?
2 sine theta.
Let's do that. Let's pull out a 2 sine theta. When you factor 2 sine theta out of itself, you leave behind 1. When you factor it out of 2 sine theta cosine theta, you just leave behind cosine theta. Good. We now have the left side completely factored, and that was a trick we learned yesterday. Now that both sides are the left side's completely factored, we set both factors equal to 0, and then we have to solve 2 different trig equations. So now we just have to solve both these equations and we'll have our solutions. Solving this one for theta, we divide both sides by 2. And we get the sine of theta is equal to 0. Question, ladies and gentlemen, the sine of what angle or angles gives us 0? The sine of what quadrantal angles gives us 0? You remember? Unit circle, where the y coordinate is 0. For what points is the y coordinate 0? The y coordinate is 0, and that occurs at what quadrantal angle? 0 degrees and 180 degrees. There's two solutions to our trig equation, 0 and 180. That one's been solved. Now we got to solve this one. We do so by subtracting 1 from both sides to solve for the cosine of theta. Now, the cosine of what angle gives you -1? What point on the unit circle has an x coordinate of -1? And what angle does it lie at? Anybody? Cosine of what angle gives you -1?
Is it 180?
180 degrees. Yep, because this is the point -1, 0 out here. So the cosine of 180 degrees is -1. And that's the only solution to this equation here on the interval from 0 to 360. But look at, ladies, and we already listed 180 degrees, so we don't have to list it twice. So your answers, your solutions to this trig equation would be 0 and 180 degrees. That's it. And we're done with that problem there. Okay. Any questions how we solve this one? So notice we're having at times tap into some previous identities that we dealt with in the past. That's another thing that often is needed, is using an identity to help us solve our equation. Here we had to use the double angle identity for sine to get us moving in the right direction. All right. Any other questions on this one? There was one like number 10. You see any other one you would like to see solved here? 1 through 16, anybody? Problems 1 through 16. You want me to solve any other ones in here? Or are we good for those or not?
$13.
13 maybe? All right, right there, 13. All right, let's take a look at 13. When we, at first glance, we notice that it does have two different trig functions involved, namely a cosine versus a sine. Further complication to this equation is the fact that the argument of the cosine function is not just x, it's 2x. That's a big complication there. Something has to be done with that. Notice our answers, since our argument is x and not theta, our answers will be radians on the interval from 0 to 2 pi. How are we going to kick this one off, ladies and gentlemen? What is the most complicated term in this equation? Let me ask you that question here. The most complicated term in this equation.
Cosine of 2x.
Cosine of 2x. We have to do something with this. We can't have this argument be 2x. It has to be x because we only have an argument of x here for the sine function. What identity, there's your hint, what identity will we use to replace this with something else?
Double angle formula.
Okay, double angle formula for the cosine function. And remember, there were 3 different versions of that. What would be the appropriate version to use, knowing that we have a sine x function in our equation? Would we use this version, cosine squared x minus sine squared x? Or would we use this version, 1 minus 2 sine squared x? Or would we use this version, 2 cosine squared x minus 1? What version, ladies and gentlemen, would be the wise way to go in the context of our situation?
Number 2.
Let's go with this one. Let's replace cosine 2x with this guy right here. So 1 minus 2 sine squared x. Okay, that's, yeah, you want to go with this version because now your equation only involves the sine function. And notice the arguments of all the sine functions are just x. So we're moving in the right direction now. Combining these like constant terms here, 1 minus 2, combine to give you -1. And now where would we go from here? What would we want to do from here? Anybody? You know, I'm thinking back to algebra. I'm thinking back to like a polynomial. This is not written in descending order. Remember, for a trinomial to be in descending order, the powers have to decrease strictly from left to right, term by term. We have a 0th degree term, 2nd degree term, 1st degree term, and sine x. Let's at least write this in descending order. So let's rearrange these terms. So now this equation is in descending order. Harmless thing to do. And now, ladies, what I'm thinking now next here is I'm thinking this is analogous to like a trinomial back in algebra. Again, a u substitution might help. Let u be equal to the sine of x. If u is the sine of x, then our equation can be rewritten as -2u squared minus 3u minus 1 equals 0. Comes down to this, ladies and gentlemen, can we factor this trinomial? And you know what? If you don't like this leading negative sign, feel free to multiply both sides of your equation by a -1 to clear out this leading negative sign here. So if I multiply both sides of this equation by a -1, I'll have then 2u squared plus 3u plus 1 is equal to 0. Now, does anybody know, ladies and gentlemen, how this would factor? How would this trinomial factor back in algebra? Can it be factored? Is it factorable? Or are we going to have to use the quadratic formula to solve this quadratic equation? Well, let's see if it's factorable. Here's the test. You take the product of the leading coefficient and the constant term, 2 times 1. 2 times 1 is 2. Are there 2 factors of 2 that sum up to the middle coefficient of +3? 2 factors of 2 that sum up to 3, do they exist?
Just 2 and 1, right?
Yeah, 1 and 2. Notice 1 and 2 are factors of 2 that add up to our middle coefficient of 3. So this guy will factor. Now, does anybody need to see how we factor this using the grouping method? I don't know. I mean, I don't know how you factor trinomials in this class. Do you use the grouping method? Do you use the guess and check or the trial and error method? Or do you use some other technique? I frankly don't care what method you use, by the way. We just got to get this factored here. It has to get factored. So maybe I'll just leave that up to you as to how you're going to factor this, ladies. But when you get done factoring, it will factor into the product of 2 binomials of the form of 2u there, u here, plus 1 here, and plus 1 here. So that's how that trinomial would factor. If you were to FOIL this all out, gather together like terms, you would get this trinomial back. Now we set our factors equal to 0. But ladies and gentlemen, we were not being asked to solve for u. We were being asked to solve for x, which is the argument of a trig function, specifically the argument of the sine function, because we let u be equal to sine x. So we need to bring back and replace u with sine x. So we're really having to solve this trig equation, 2 sine x plus 1 equals 0. Sine x plus 1 equals 0. These are the equations we have to solve for. Subtracting 1 from both sides, dividing by 2, you get the sine of x is equal to -1/2. Since the sine of some angle x is negative, a negative ratio, that would confine us to what? The quadrants of number 3 and 4, correct? So the only solutions to this equation are going to come from the quadrant 3 and 4. Using your unit circle or using your triangle, 30, 60, 90. The sine of what angle, ladies and gentlemen, gives us -1/2? What would be our third quadrant angle whose sine is -1/2? Anybody? You can use your unit circle again.
I want to say 7 pi 6.
Just use your unit circle here. The sine function is the y coordinate of your ordered pair. So you're looking for an ordered pair that has -1/2 as its y coordinate. And you said this occurs at what? What was that, 7 pi 6?
Yes, I believe so.
Okay, so one of our solutions to this equation is x equals 7 pi 6. That's your third quadrant answer. But there's also a fourth quadrant answer because the sine of a fourth quadrant angle is also a negative. So there's going to be another angle in the fourth quadrant here to here. That's going to be another solution. Can you see what that other angle is? Maybe using your unit circle?
11 pi 6.
11 pi 6, exactly. Because if you look at your unit circle, the ordered pair associated with this point here, that's 11 pi 6 away from the positive x-axis. The y coordinate is -1/2, so 11 pi 6. Or knowing that our third quadrant answer is 7 pi 6, knowing then that the reference angle here to here is pi 6, you could have used pi 6 as a reference angle for your fourth quadrant answer. In taking 2 pi or 12 pi 6, subtracting off pi 6, right? 2 pi all the way around, 2 pi or 12 pi 6 minus pi 6 is 11 pi 6. All right, we just have this equation to solve and we'll wrap this problem up. To solve this one, we subtract 1 from both sides. The sine of what angle or angles x is equal to -1? What angle has a point or an ordered pair on unit circle with a y coordinate of -1? What angle is this down here? Sine of what quadrantal angle is this? This is
3 pi halves.
3 pi halves. 3 pi halves. And we're finally done with this problem. So these are all your solutions to that trigonometric equation there. 7 pi 6, 11 pi 6, and 3 pi halves. And we're done with this problem. Again, ladies and gentlemen, you don't have to do a U substitution. If you can factor this, directly into 2 times the sine of x plus 1 times sine of x plus 1, that's just going to speed the process up. That's more power to you if you can do this. I like to at times use U substitutions to try to help us see the forest for the trees. It actually takes us back to algebra. It's easier to see what we need to do here. You got to factor a trinomial here, and we did so. Just don't forget to back substitute in what am I trying to say? Just don't forget to bring back what U was set equal to. U was set equal to sine x back up here, so that's why you got to eventually bring back sine x. Got to bring back sine x in place of U. Okay, don't forget to do that. Any other questions about this problem here? One like number 13 there. So again, we had to make use of an identity, in this case, the double angle identity for cosine, to help us move along the solution process for this equation. Okay, so that one's solved. All right, are there any other problems in this batch that you would like to see done, 1 through 16? Or are you confident now in being able to probably handle any one of those? Unless you indicate, I will assume we're all happy with those problems there, 1 through 16. Let's move on. All right, the plot continues to thicken as we move on down the line here. All right, so on page 303, we have yet more equations that we need to solve here. All right. And like I said, they all look a little different here. Notice everyone's a little bit different. And that's for that reason, it's imperative, ladies and gentlemen, that you try to do as many of these problems as possible. Number 22 here. Got a question for you. Look at number, everybody look at number 22. 2 times the cosine of x plus the tangent of x is equal to the secant of x. Tangent is sine x over cosine x. Secant x is 1 over cosine x. What would we multiply both sides of this equation by? Ladies and gentlemen, to get rid of our fractions of sine x over cosine x and 1 over cosine x?
Cosine X.
You would multiply both sides of this equation by cosine x to get you moving in the right direction. All right. That's a common trick we've already seen this morning. All right, backing up to problem number 20. To solve this equation for x, notice we got cosine squared x mixed in with sine x. Not a good thing. We would like to reduce this equation down to only one type of trig function, either all sines or all cosines. What identity could I use to replace cosine x with an equivalent sine x expression? What identity would I use to replace cosine x with? And what would that choice be? Remember, this is the well, maybe we better do 20. It's not the double angle identity for cosine. That's just cosine squared x. What's another name for cosine squared x?
1 minus sine squared x.
Yep, Pythagorean identity. This is one of the first identities we've seen several weeks ago. Recall that sine squared x plus cosine squared x is equal to 1, which implies then that cosine squared x would be equal to 1 minus sine squared x as an equivalent form of our Pythagorean identity. So we can replace this cosine squared x then with 1 minus sine squared x. Now we're moving in the right direction because we have our trig equation down to only one type of trig function, namely the sine of x. Distributing the 4. Combining like terms, 4 minus the 5 way down here is -1. Rearranging this to put this in descending order. Maybe multiplying through by a -1 to clear out the leading negative sign. Leading negative signs are nasty in polynomials back in algebra. And that's also the case for trig equations. Just multiply both sides of the equation by a -1. The effect that has is just to toggle all the signs of all the terms. Ladies and gentlemen, this is analogous to what type of trinomial back in algebra? If you let u be the sine of x, this is analogous to 4u squared plus 4u plus 1 equals 0. You agree? Isn't this the same structure as this back in algebra? Now, can we factor this? Anybody remember how this would factor? Or would it factor? 4 times 1 is 4. Are there 2 factors of 4 that sum up to the middle coefficient of 4?
Yes.
What would they be?
2 and 2.
2 and 2. That means this thing is factorable. So a quick, slick way to determine if a trinomial is factorable is there must be factors of the product of the leading coefficient and the constant term that add up to the middle coefficient. If you can find them, then it's factorable. If you can't find them, it's not factorable. Well, however you factor this, I'm going to leave that up to you. I'm sure all of us have our own little happy way of factoring trinomials by now. Okay, some may use the grouping method, some just might use trial and error method, the brute force method. At any rate, ladies and gentlemen, how would this factor? Well, I think it would factor into 2u plus 1 times 2u plus 1. Do you agree? In fact, this turns out to be, I believe, what, a perfect square trinomial. Isn't that the case? This is a perfect square trinomial because it factors into identical binomials. Therefore, this trig equation left side would factor according to this. So the left side of this trig equation would factor into 2 sine x plus 1 times 2 sine x plus 1. Now that we completely factored the left side of our trigonometric equation, we set both factors equal to 0, which in this case is redundant because we have 2 identical factors. So we don't have to, do this twice. All we got to do is take one of these factors, set it equal to 0, and then solve this equation. Minus 1 from both sides, divide both sides by 2. We'll have the sine of x is equal to -1/2. Since the sine of our angle is a negative ratio, that means our angle must come from quadrants 3 or 4. So I'm using your unit circle or whatever method you have adopted to this point in the course. The sine of what third quadrant angle would give you -1/2? Use your unit.
7 pi 6.
All right, so 7 pi 6. That's one solution. So if this is 7 pi 6, we know the reference angle here is pi 6. Isn't that the case? Because here to here is 6 pi 6 or pi, and 6 pi 6 plus another pi 6 is 7 pi 6. You could use that reference angle to derive your fourth quadrant answer. Because we know all the way around is 2 pi, or better known as 12 pi 6. So what's 12 pi 6 minus pi 6? That'll be your fourth quadrant angle here. That would be 11 pi 6. And there we go. There's your answers, and we're done. Those are your 2 solutions of this equation, 7 pi 6 and 11 pi 6. To help us here, again, we had to tap into an identity, in this case, a Pythagorean identity, to rewrite cosine squared x as 1 minus sine squared x. And then we moved on from there. And notice again, we also had to get down to a point where we had to factor an analogous trinomial, what looks like a trinomial back in algebra. We had to factor, okay? All right, that was one like number 20. Okay, well, that's just great. All right. That's beautiful. Ladies and gentlemen, how are we going to solve one like number 24? 24 looks pretty innocent, doesn't it? Be on guard for innocent looking math problems. They can be some of the most difficult ones. How would we begin to address solving this equation? Sine of theta minus the cosine of theta is equal to the square root of 2. Some of you might be adept enough, ladies and gentlemen, to just determine what our solution would be here. What ratio minus another ratio would give you the square root of 2? That's not obvious. All right, so how are we going to do this problem here? The problem is that we got 2 different trig functions, and that's no good. If we zero this equation out by subtracting square root of 2 from both sides, we're still going to be in the same boat. It's still going to be a difficult situation to deal with. Nothing appears to be working here, ladies and gentlemen. Nothing at all. So what are we going to do here? Anybody got a suggestion? let me give you a hint. With this left side, is there anything I can do to the left side so that we can eventually tap into some of our, maybe an identity we've learned in the past? Is there anything we can do to this left side so we can tap into an identity? Anybody? Any ideas at all? You might want to take a shot. We don't really have an identity for just sine of theta or cosine theta, but ladies and gentlemen, we do have our what? Pythagorean identities, but the problem with the Pythagorean identity is the fact that the sine and cosine function have to be what? Squared. They have to be squared to be able to maybe tap into one of the, maybe this identity here of some sort. All right, so we seem to be having a problem with that. Tell you what, before I square both sides, let's just try to isolate one of these trig functions on the left side. Let's try to isolate the sine function. So let's add cosine theta to bring it over to the right side. So now our trig equation looks like this. Cosine theta drops out on the left side, and we got it down to what looks like a fairly innocent problem equation here. Down to this. Now I'm going to square both sides of this equation. And the reason why I'm going to square both sides is because then I can begin to tap into my Pythagorean identity. Because right now there's no identity that I can really use here. Let's square both sides. Square the left side, and then you got to square the right side. Squaring the right side involves foiling this out, if you will, borrowing the algorithm from algebra to foil this out. Square root of 2 times itself is the square root of 4, but the square root of 4 is 2. Square root of 2 times cosine theta is the square root of 2 cosine theta. Cosine theta times the square root of 2 is another square root of 2 cosine theta. Cosine theta times cosine theta is cosine squared theta. Right side of our equation, combine these two middle terms. So 1 square root of 2 times the cosine of theta plus another one is going to give you 2 of those square roots of 2 cosine theta. The bad news is we still have 2 different trig functions involved in this equation, sine versus cosine. But what can I replace this with using now my Pythagorean identity? Another name for sine squared theta is 1 minus cosine squared theta. Let's replace sine squared theta with 1 minus cosine squared theta. The good news now is the fact that our equation has been reduced down to only one type of trig function, namely the cosine. The bad news is it looks like there's a lot more work that needs to be done. So we're not done yet. Anybody understand what's happened up to this point? Let's drag everything over to one side of our equation. I'm going to bring these 2 terms over to the right side. So I'm going to subtract 1 from both sides, and I'm going to add cosine squared theta to both sides. When we do that, the left side of our equation becomes 0. The right side becomes just 1 plus 2 square root of 2 cosine theta. Cosine squared theta plus another cosine squared theta is 2 cosine squared theta. We got it down to this. Well, that sure is nasty looking, isn't it? But we got it down to that. Well, how are we gonna deal with that then? We'll go back to that problem. We'll take a look at the instructions here. Well, instructions are still the same for all of these here. Well, what we got here is we have this equation. And somehow, some way, we have to solve this equation for theta. Notice there's nothing you can factor out of all three terms, except one or -1. It kind of looks analogous to like a trinomial, but the middle coefficient is a real mess. You agree? Middle coefficient's a mess. Anybody know a way out of this little jam here? It's not obvious. It's a pretty tough problem there. Let's see. Let's see what we can do here. We got, let's see, square root of 2. Two times 1, ladies and gentlemen, is 2. Are there any factors of 2 that sum up to 2 square root of 2? Watch this. What's the square root of 2 times the square root of 2? That gives you the square root of 4, which is what, 2? And ladies and gentlemen, what's the square root of 2 plus the square root of 2? That gives you 2 square root of 2. You know how this is going to factor? It would factor in the square root of 2u plus 1 times the square root of 2u plus 1. That's completely factored. Let's try it out. Square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 is just 2. Square root of 2u times 1 is the square root of 2u plus another 1 times the square root of 2u is 2 square root of 2u's. 1 times 1 is the last term 1. So this will work. I mean, this trinomial does factor. So the left side of this equation will factor into the square root of 2 cosine theta plus 1 times itself. Since these factors are identical, you don't have to set both of them equal to 0. Just set one of them equal to 0 and solve for theta. Subtracting 1 from both sides, dividing both sides by the square root of 2, we therefore get the cosine of theta. So this implies we get cosine of theta is equal to -1 over the square root of 2. Or the cosine of theta is equal to negative square root of 2 over 2. Using your unit circle, ladies and gentlemen, since our answers or solutions can come from the second or third quadrant, because the cosine is a negative ratio, what angles would that afford us? When I see square root of 2 over 2, I'm thinking of the 45, 45, 90 triangle. So I'm thinking the cosine of 45 degrees, ladies and gentlemen, is 1 over the square root of 2. So we would use 45 degrees as a reference angle to get our third quadrant and our fourth and our second quadrant angles. So what would those be? Second quadrant angle, if this is 45 degrees, what angle would this have to be there here to here? It'd be 180 minus 45, which is 135 degrees.
3 pi over 4.
Yeah, our answers are gonna be in degrees because we have
Oh.
theta for the argument here. When you
My
have
bad.
theta, your answers are degrees. When you have X, your answers are in radians. So we'll call that 135 degrees. And then we'll use 45 degrees as a reference angle for our third quadrant possible answer. So what's 180 degrees plus 45 more degrees? I believe that gives us what, 225 degrees? We're finally done with this nasty problem. You know, what's amazing is this equation looked so innocent. And yet it got us into a street fight here, Elizabeth. But we were able to solve it. 135 degrees and 225 degrees. Now, might there have been another way to have solved this this equation? Another thing you don't want to do that. Let's just leave it at let's leave it like this, okay? Isn't that interesting to see that this trinomial and u factors into the product of these identical binomial factors? That's not obvious, is it? Factoring this into this, though. It's not obvious. That's a tricky one to factor. Okay, I'm gonna leave that one as is. That was one like number 24. Let's see. Let's get down into one like number 30 here. The sine of x over 2 plus the cosine of x equals 1. We want to solve this trigonometric equation, and notice our solutions must lie between 0 and 2 pi. I'm open to suggestions, ladies and gentlemen. Why does this equation initially present itself as being very nasty? Why is this a difficult looking situation here as is? Why does this equation look very difficult at this point in time?
Because you have sine and cosine x, and then you also have sine as a half angle identity.
Yeah, we got a lot of complications here. For one thing, we have two different types of trig functions in this equation, sine versus cosine. We usually like to get our equation down to only involving one trig function, if possible. Another major complication, probably more important, is the fact that the argument of this sine function is not just x, it's x over 2. Here, the argument's just x. That's a huge hurdle to overcome, okay? It's quite a barrier here. But to the rescue, I think, Sean, you said that we will what? Replace this with using what identity?
Half angle identity, which means that sine of x over 2 is equal to plus or minus the square root of 1 minus cosine of x divided by 2.
Over what?
Over 2.
This is over 2 here?
Yeah.
Okay, that is over 2. I just want to make sure that we got that right. So this is the correct identity for the half angle for sine, correct? Say that it's this. All right. It's not over 1 plus cosine x. It's not 1 plus cosine x down here. It's just over 2.
Yeah, the 1 plus cosine x is the cosine x over 2 identity.
Okay, cosine x over 2 would be 1 plus cosine x over 2.
Yes.
Okay. We'll go with this. So here's what we're gonna do. We're gonna replace this nasty term here, sine of x over 2 with this. So this is gonna be replaced with plus or minus the square root of . The good news is at least we have our trig equation reduced down to one type of trig function, namely cosine, and the arguments are all just x now. That's the good news. The bad news is we have a nasty square root here on the left side. How ugly this looks. Tell you what, do you remember back in algebra when solving radical equations or square root equations in particular, that you always wanted to isolate the what? Isolate the radical on one side of your equation. So what I'm going to do is I'm going to subtract cosine x from both sides of this equation to get this square root all by itself on the left side. Let's do that. Let's isolate the radical. And again, that's accomplished by subtracting cosine x from both sides of our equation. Now, what we've accomplished is we have the square root all by itself on the left side of our equation. And how do we get rid of a square root? We square it, but we also therefore have to square the right side of our equation. When you square a square root, the square root disappears. Furthermore, if you take a plus or a minus and square it, it's always going to come out to be a plus. I don't care if it's a plus or a minus. When you square it, it's always a plus. So this is just going to reduce down to 1 minus cosine x over 2. Radical is gone. On the right side, we're going to have to FOIL this out. So this is going to be like 1 minus your cosine x times itself. 1 times 1 is 1. 1 times negative cosine x is negative cosine x. Negative cosine x times 1 is another minus cosine x. Negative cosine x times negative cosine x is plus cosine squared x. Cleaning up the right side by combining like terms. Let's get rid of this fraction here, and we can do that by multiplying both sides of our equation by 2. Got to multiply the left side by 2 also. These 2's cross cancel out, leaving you with 1 minus cosine x. On the right side, this 2 distributes into all of these terms. So we'll have 2 minus 4 cosine x plus 2 cosine squared x. And now all we want to do is zero this equation out because it looks like it's going to be analogous to a quadratic equation because we have a second degree term here in cosine x. So let's add cosine x to both sides. Subtract 1 from both sides. By doing all this, the left side of our equation becomes 0. The right side of our equation, 2 minus 1 is 1. Negative 4 cosine x plus 1 cosine x is minus 3 cosine x. Spinning this whole equation around because I don't like 0 on the left side. Ladies and gentlemen, is this factorable? Notice it's analogous to a trinomial in algebra, 2u squared minus 3u plus 1 equals 0. It's analogous to this. Does this trinomial even factor? Test. 2 times 1 is 2. Are there factors of 2 here that sum up to negative 3? 2 factors of 2 that add up to negative 3. Negative 1 and negative 2. So yes, this does factor. How does it factor? Well, I think it's going to have to be 2u that have a u minus 1. That'll give you negative 2u plus another minus u will give you negative 3u. So that's how that will factor. So this left side is going to factor in a similar way. It's going to factor into 2 cosine x minus 1 times cosine x minus 1. The left side factors into this. Setting both these factors equal to 0. We'll solve that trig equation, and we're going to solve this one right here. Solving this one, we add 1 to both sides, divide both sides by 2. We'll have cosine x is equal to 1/2. Here we add 1 to both sides, the cosine of x of which is equal to 1. Ladies and gentlemen, the cosine of what first or fourth quadrant angle gives me positive 1/2? The cosine of what angle in general gives you 1/2? Think of the 30, 60, 90 triangle.
60.
You're saying the cosine of 60 degrees. All right. But it has to be in radians. So 60 degrees is
Pi thirds.
pi thirds. We also need our fourth quadrant answer. We got our first quadrant answer, which is pi third or 60 degrees. To get our fourth quadrant answer down here,
5 pi thirds.
we're going to use pi thirds. Think of all the way around, ladies and gentlemen, is 2 pi. Well, 2 pi is better known as 3 pi, excuse me, better known as 6 pi thirds. 2 pi is 6 pi thirds. So what's 6 pi thirds? Subtract off pi thirds. That would be 5 pi thirds. There's 2 solutions of this equation. And the cosine of what quadrantal angle gives you positive 1? Think of your unit circle again. What ordered pair has an x coordinate of 1 because the cosine of an angle is akin to the x coordinate for the unit circle? Well, what angle is this? 0 or what? 2 pi.
0, 2 pi.
Yeah, you can say either one, believe it or not. You can say 0 or 2 pi. I mean, they're coterminal with one another. These angles are coterminal. So I'll just say another solution is, I'm going to say 0. Another solution is 0. 0 radians. This is radians now, not degrees. Oh. Well, if 2 pi is included on the interval, which it is, ladies and gentlemen, 2 pi is included in the interval, so is 0. Yeah, we better just play it safe, and x is also equal to 2 pi. Say both of these. I know these are coterminal angles, but you better state both of them. There's all your solutions here to this trig equation that forced us to use the half angle identity for sine so that we could get our argument down from x over 2 down to an argument of just simply x throughout our entire equation here. Quite a problem, isn't it? So you can see, if nothing else, our patience and perseverance is going to be really tested in trying to solve some of these equations in section 6.2. Don't get frustrated, ladies and gentlemen, and think the problem's going too long and you're doing something wrong. Sometimes these problems just require quite a bit of time to actually get down to the final answers. That's the case usually the higher you go in mathematics. Problems get longer and longer and longer and longer and longer. All right. You'll see that to be the case if you keep going in math. All right. Any other questions about this problem here? That was a real good one. Beauty. A lot going on there. All right. Classwork. I want you to do a couple of problems for me, ladies and gentlemen, for classwork today. Today is August 11th. Problem number 1. I'm going to look through some of these problems here and see if I can come up with maybe 1 or 2 that I'd like you to do. All right, I want you to do number 21, which says they want you to solve the 2 times the sine of x plus cotangent x minus cosecant x equals 0. Solve. And notice x lies on the interval from 0 to 2 pi. That's problem number 1. Number 2, I want you to solve. Okay. Next problem I want you to solve is one like, number 9, the sine of 2 theta minus the cosine of theta is equal to 0. And notice now your solutions will be degrees, from 0 degrees to 360. There you go, Linda. Those are the problems I want you to solve. All right, I'll give you time to work on those. Okay, so problem number 1 on the classwork here. Notice I replaced cotangent x with cosine x over sine x, replace cosecant x with 1 over sine x. I then multiplied both sides of this equation by the sine of x to knock out these two fractions here. But you got to multiply each term by sine x on both sides of the equation. When you do that, you'll get your equation down to this. Because we have two different trig functions in this equation, we want to get it down to one trig function if possible. I replace sine squared x with 1 minus cosine squared x, Pythagorean identity. Distributed to 2 inside the parentheses here, and we got this. So now this is the equation we have to solve. Rearranging it to get it into descending order. I multiplied both sides of the equation here by -1 to clear out that leading negative sign. This equation is analogous to this trinomial back in algebra. This quadratic equation. And this left side will factor. Therefore, 2 cosine squared x minus cosine x minus 1 factors into 2 cosine x plus 1 times cosine x minus 1. Setting both these factors equal to 0. Simplifying each equation down. Solutions of this equation, cosine x equals -1/2, would be 2 pi thirds and 5 pi thirds. Simplifying this equation down to cosine x equals 1, the only solutions to this trig equation would be 0 and 2 pi. Those are all your solutions to number 1. Number 2, notice we have sine of 2 theta. Because the argument is 2 theta instead of just theta, that's a complication. But to the rescue is the double angle identity for the sine function. So this can be replaced with 2 sine theta cosine theta. And our equation then looks like this. I then factored out a cosine theta out of both these terms. Equation looks like this. I then set both factors equal to 0. And then we have 2 simple trig equations to solve. This one is very simple. The cosine of what angles gives you 0? Well, that'll be 90 degrees and 270 degrees. After simplifying this equation down, we get it down to sine theta is equal to 1/2. Well, that occurs when theta is equal to 30 degrees and 150 degrees. These are all your solutions to that trig equation. All right, ladies and gentlemen, take care. Have a good day.